But I'm Dr. Jeff Becerra. I'm the director of the Kessler Atmospheric and Ecological Field Station here at the University of Oklahoma. It's actually about a 400-acre field station located in rural McLean County, about 15 miles to the southwest of the main campus of the University of Oklahoma. And out on this field station, we have a number of different projects that have spanned across a wide range of activities in interdisciplinary science, from meteorology through biology, hydrology, and even some engineering. And this field station is only possible due to the generous gift of Dr. Ed Kessler and his family. Dr. Ed Kessler was the director, the original director of the National Severe Storms Laboratory when it was founded here in Norman, Oklahoma in the early 1960s. And this was actually his homestead where he lived, and he had purchased this land and lived on this land. But Dr. Ed Kessler was fascinated not only by what processes happened in the atmosphere, but he was a naturalist and loved to spend his time working across his property. And he invited biologists, ecologists out here to work on his property to make fundamental new discoveries about the processes in ecology here in central Oklahoma. And upon his retirement, he donated this land to the University of Oklahoma. And this land has now become a field station that is an asset to the students and faculty of the University of Oklahoma and other universities as well, trying to understand many of the complex processes that happen between the surface, the atmosphere, and the entire environment here in central Oklahoma. One of the key assets of the Kessler Atmospheric and Ecological Field Station are the real-time observations that we collect on site here at the field station. And behind me is an Oklahoma Mesonet station. And the Oklahoma Mesonet is a network of 120 stations across the state of Oklahoma, and they have been established since 1994. They collect real-time observations of weather and climate information and observations in the soil as well. And all of this information is collected from all the stations all the time at 5-minute intervals, transmitted back to the University of Oklahoma, and then provided to the citizens of the state of Oklahoma as well as students and researchers at the university. And this station behind me is actually an important station. It has been here since 1994. It's one of our original stations in the Oklahoma Mesonet. And we now have a fantastic climatological record of atmospheric and environmental conditions here at the field station. One of the most iconic images of the Kessler Atmospheric and Ecological Field Station is the windmill. It's actually the oldest working windmill in all of McLean County, and it dates back to the late 1800s, and that's a key aspect of what the Kessler Atmospheric and Ecological Field Station represents. It represents history. It represents history of human settlement in an ecological condition in central Oklahoma that now we have the privilege to be able to observe and monitor with a wide range of atmospheric and ecological observation systems. One of the more recent technologies that's being developed at the University of Oklahoma and tested out here at the Kessler Atmospheric and Ecological Field Station is the use of unmanned aerial systems, UAVs or drones, to collect weather and climate observations using different types of systems that collect vertical profiles of atmospheric variables, including temperature, humidity, but also looking back down at the land surface and monitoring the vegetation and soil moisture. While it's important to measure atmospheric variables like temperature and moisture and precipitation, it's also critical to measure the transport of those variables. And this type of station that's behind me is the Kessler Atmospheric and Ecological Flux Tower. And this station is critically important in that it allows us to measure the transport of mass and energy between the land surface and the atmosphere. So we actually measure water vapor as it leaves the surface through the vegetation and moves to the atmosphere. We also measure that atmospheric moisture moving from the atmosphere back to the vegetation. And at the same time, we can also measure carbon dioxide from the land surface to the atmosphere and from the atmosphere back to the land surface. And this gives us a much better understanding of how the atmosphere and the ecosystem are interacting. And so when we collect these long-term measurements, it's critically important. This forms the backbone of many of our observations and our research that's being done in the climate, hydrology, ecosystems, and weather research group, in that it allows us to understand these exchanges across a wide variety of environmental conditions.